Okay, question 13. A rectangular triangle drawn on square paper. Work out the ratio of the area of the rectangle to the area of the triangle. Okay, so first of all, the area of the rectangle, 1, 2, 3, 4, 5. 1, 2, 3, so the area is going to be 15. It could be centimetres squared, but seeing it doesn't W, and I'll just leave it with the numbers. 1, 2, 3, 4. 1, 2, 3, 4. So 4 times 4 is 16, and half it is 8. Just remember the area of a triangle is base times height over 2, and the area of a rectangle is just the base times the height. So we've got the area of the rectangle is 15, area of the triangle is 8. Now, it doesn't necessarily say to simplify, but what I could do is just put in my calculator 15 divided by 8, and that still comes out as a fraction as 15 over 8, so I know that it's in its simplest form, but because it didn't even ask you to simplify, I would just leave it as 15 over 8, even if these two numbers could simplify. A box contains cards that are either red, blue, green or yellow. The probability green is equal to the probability of yellow. Okay, so that means that these two numbers are equal. Complete the table. So because it just involves red, blue, green and yellow, we know that they must all add up to 1. So if I do 1 minus 0.1 minus 0.24, I'll get what my answer is. So again, I'm going to use my calculator, even though I may be able to do it in my head. I'm still going to use my calculator just to double check. So we end up getting an answer of 0.66. So 0.66, and then what we're going to need to do is, because they're equal, we're going to have to do 0.66 divided by 2, which gets us 0.33. 0.33. And again, we could check by adding them all up and making sure it comes to 1. There are 600 cards in the box. How many cards are not blue? Okay, so if the probability of blue, so probability of blue is 0.24, the probability of blue not is going to have to be 1 minus 0.24, and again, even although I can do it within my head, we're going to check in our calculator and we get 0.76. So that's the probability of blue. 600 cards in the box, so we're going to do how many cards are not blue. It's going to be 600 multiplied by 0.76. So 600 times by 0.76 gets me 456. So we get 456. Now that's not the only way of doing it. We could have worked out how many are blue and then take it away. But if we know that, we know what the probability of blue is, we know that the rest must be not blue. So that's the two ways of doing that one. Question 15, A and B are triangles. Okay, so there's triangle A, there's triangle B, just so I've got something to go with in my head. For each statement, tick the box that describes. So A's sides are the same lengths as B sides. So if they were the same, so for example 3, 4, 5, and this was 3, 4, 5, then that means it must be congruent. Congruent means identical in every way, so that means that all the sides are the same, and all the angles would have to be the same as well, and it's got to look the same, it's got to be the same shape. A's angles are the same as B's angles, so A's angles and B angles, that will only sometimes be congruent, because it could be that these angles are all the same as these all angles, but we could have multiplied this by 2 to get 6, 8 and 10. They would still have the same angles, but the dimensions would be different, so therefore it wouldn't be congruent. But there could be occasions that it is the thing, so we can only say sometimes. A is an enlargement of B with a scale factor of 2. Well, that's never going to be congruent, because congruent means identical in all ways. Okay, question 16. Here's an equilateral triangle. So as I'm doing an equilateral triangle, I'm going to add that into my diagram just to remind me of what that first sentence is. all measurements are in centimetres. Work out the value of the perimeter. Okay, so this is actually wanting me to do the perimeter, so it looks as though there's going to be a number of steps. I'm also looking at it's worth 4 marks. So first of all, I know that these dimensions must be equal to each other. So I'm going to have to, I could create an expression to say that, well, 6x take away 8 is equal to 2x plus 12. Now, because this has only got one unknown, we can solve this. So in order to solve it, I'm going to identify which side's got the least amount of x's and remove them from both sides. So 6 take away 2 is 4x, take away 8 is equal to 12, because 2 take away 2 is nothing. I'm then going to add 8 to both sides, because that's the opposite, taking away 8. So we end up with 4x is equal to 20. And then I'm going to divide by 4 to get that x is equal to 5. Now the temptation is you've done a lot of work there and you think, oh, excellent, I'm done. It's asking me to work out the value of the perimeter. So what I'm going to have to do is I know that x is equal to 5 because I've just worked it out. So 6 times 5 take away 8. So 30 take away 8 is 22. Now I'm going to check, because in theory this should come out exactly the same. So I'm not going to just put down 22, I'm actually going to check it. 2 times 5 plus 12, 10 plus 12 is 22. Excellent. Now I know for certain that I've got my x value right. Again, these lines mean that they're all the same, which means that this is 22. So now I need to work out the perimeter. The perimeter is going to be 22 plus 22 plus 22. Again, I'd pop it in my calculator just to double check I don't make a silly mistake. 20, 40, 60, 246, so 66. Okay, question 17. Sid and Zach each throw the same biased coin. Okay, so that means it's not 50-50 of landing on. Here is some information about the throws. So Sid done 80 throws and the relative frequency. So relative frequency is kind of probability. But it's when you're carrying out an experiment, so it's called relative frequency, is 0.75. Zach has 120 throws and 72 are heads. So first of all, I'm just going to underline that these are both heads that we're talking about. Work out the relative frequency of heads for the 200 throws. So for the 200 throws, it's going to be them added together, which gets me 200, which means we're going to have to combine these ones together as well. So if we've got 72 are heads, we are probably going to have to work out how many, well, there's 2 different ways of doing it. I'm actually probably going to work out how many heads there was here. So if I've got 0.75 multiplied by 80, that will tell me how many heads there was. So 0.75 times by 80 gets me 60 heads, which means I am going to, so this is the equivalent of 60 heads, that's 72. So if I add them together, so add 72, we get 132. So therefore the relative frequency of all 300 then is going to be 132 over 200. Now I can't just leave it like that. If I put it in my calculator, it will tell me the decimal equivalent of 33 over 50. Okay, but 132 over 50 would be fine, or we could say 66%. Okay, now there is different ways of doing that as well. Which result would give the best estimate of the probability of heads? Okay, so we always want to do the most amount of throws. So the more trials, the closer we get to actual probability.